Welcome to ESG Decoded, where we navigate the evolving landscape of environmental, social, and governance, ESG. Join me, Amanda Kuhl, Erika Schiller, and Anna Stablum as we explore the intersection of sustainability, innovation, and ethical leadership, the dynamic forces shaping our global economy.
Hello, everyone, and welcome back to ESG Decoded. I'm your host, Erika Schiller, and today I'm joined by Simon Ninan. Simon and I are going to talk about artificial intelligence and how it relates to energy usage and sustainability. Both are there opportunities to use AI to improve how we measure sustainability, how we use our infrastructure, in addition to what are the impacts of the incredible expansion in AI and the demands for energy to power all of these large language models, LLMs. Simon joins us as the SVP or Senior Vice President of Business Strategy and Sustainability at Hitachi Vantara. Hitachi is a common household name, but Simon, can you share a little bit about what is the Vantara part at Hitachi Vantara and why we're talking about artificial intelligence today?
Thank you, Erika. Really good to be here. Thanks for having me on. I think your podcast is fantastic, and I look forward to this opportunity to address your audience this way. So yeah, I think you brought up that Hitachi Limited is in fact a household name. I think people know Hitachi as a big industrial conglomerate. Right now, I think it's a $70 billion annual revenue. Yeah.
Wow.
In that context, Hitachi Vantara is probably less well known of a name, but just think of it as the digital arm or the data infrastructure arm of this much bigger industrial company. Why data infrastructure in the context of an industrial company? You can think of it as, I think many people are familiar with the term Industry 4.0. When you talk about Industry 4.0, you're saying you're taking physical world and real world outcomes and combining it with the digital world. And when you bring the two together, that's where the magic happens, right? And that magic is unlocked by digitalization and by data. Data is the key to a lot of the power that we would see to drive real world outcomes. That's Hitachi Vantara's role, right? And so I represent strategy and sustainability in this data storage business. And I think I'm sure we'll unpack in this conversation, a tremendous amount of challenge ahead of us, but also potential and opportunity to drive real value for businesses, regardless of where you sit.
That's great. Thank you, Simon. And, I think it'll be beneficial to our listeners to get more into the examples as we go along. So, setting the stage, there's a lot of discussion about artificial intelligence and how it can improve the way we work or help us make better decisions, make our work easier and faster. But can you share about artificial intelligence or AI and why it's so resource intensive or carbon intensive? Talk about the sustainability problem here.
This is such a burning topic. Erika, this year itself, I've been to maybe several events where these are climate-focused events. The topic of the event is ESG, but for some reason, AI has taken center stage. And it's because of the transformation that's happened in the world over the last couple of years. It's not just that people are enamored by the hype of AI. From a climate perspective, there's a lot of doom saying. Let me kind of frame the problem for you a little bit, right? So first of all, let's put into context that there's a massive data explosion that's been happening in the world over the last 15 years. In 2010, the amount of data being generated in the world was 2 zettabytes of data a year. Just to kind of frame what is a zettabyte, it's 10 followed by 21 zeros of bytes of data being generated globally per year. That was 2010. 2025, that number is 200. From 2 to 200, it's gone up 100 times in the matter of 15 years, right? What's causing that explosion? That's pretty big, right? What's causing that explosion is a confluence of technologies, which includes IoT, blockchain, metaverse, social media, VR, ER, all of the data that we exchange with each other. But then in 2022, we had this new thread of AI that now has caused something to actually say, do we even know what the estimates are anymore? They're kind of out of control. Let me frame up the other side of the problem. Data centers obviously have been, capturing and storing data across the world, right, in a variety of formats for years and years. Today, data centers have already been acknowledged. Like even before you brought AI into the equation, data centers accounted for 3% of the world's greenhouse gas emissions. Just to put that into context, that's more than the entire airline industry. That's data centers. And for all that has been happening over the last few years, or the last several years, just over the next 5 years, this number is expected to go up 3 times. 3 times. The instigator of that is the explosion with AI, right? And so what you're actually talking about is like AI is a disproportionate contributor to the problem that we have in data centers. If you have 3% of power usage and greenhouse gas emissions today, now in 5 years' time, we basically brought it to unsustainable levels. Not just are we talking about pollution in the environment, but you're also talking about power usage and stress on the grid to levels that have never been anticipated, right? And so this comes back to why are we seeing doomsaying? It's basically people saying, guys, we need something seriously to give in the energy space and in the greenhouse gas and carbon emission space so that we can tackle this problem. Let me frame up a couple more data points for you. I know I'm throwing a lot of data points, but the reason is that the magnitude of the problem requires a big solution. Microsoft in 2020 had set that's when it set its baseline for how it was going to get to carbon neutrality. It has found that between 2020 and now, its carbon emissions have gone up by 30%, 29%, I think. And that caused a lot of people to actually really pay attention. Many of these hyperscalers and big companies are actually now backing off of commitments that they had made from a carbon neutrality and net zero perspective because they're saying, hey, this data explosion is out of control. We don't know how to handle it. Here's another data point. A single chat GPT query uses 100 times more power than the average Google search. You put 10 million chat GPT queries a day and you're talking about 1 gigawatt hour, which is enough to power 33,000 homes. That's not a small number. You want to train a new model. You talked about LLMs in your introduction. You want to train a new model. The amount of energy required to train a new model is equal to the emissions, by the way, of 5 US cars across their entire lifetime. That's crazy, right? And so when we say this is a big problem, this is why climate scientists and others are freaking out a little bit. And it requires big thinking, innovative solutions. It requires us to do something different. Yeah.
And I guess with your Microsoft example, we've seen some of the large tech companies with very recent announcements about offtake agreements in the nuclear power space. And, some of those, like 3 Mile Island in Pennsylvania, had been shut down. One of the units had been because it wasn't economic. And the announcements were Microsoft was willing to pay enough, per unit of energy to turn that defunct unit back on. And I think part of that is they're putting a value on the carbon, right? There's no price on carbon in the US necessarily, definitely not a federal price. So if you put a price on the value of avoiding coal or natural gas emissions, then, it becomes more economic to choose a green power. But the other piece is firm power, right? It's not intermittent like solar or wind. The nuclear source can be consistent. So how do you see artificial intelligence and these energy demands from data centers impacting our grid? You mentioned infrastructure needs. Can we handle this additional load? And there's a lot of work, a lot of discussion and promotion of electrify everything, right? Electrify vehicles to reduce point source emissions from the, burning gasoline or diesel in their tailpipe. Electrify our forklifts, electrify heavy duty trucking in some instances where that's feasible. So yeah, there's a lot of pressures on the grid. And are there things that AI can do to help that?
Yeah, you know what? It's a really well framed question. I framed this as an AI versus AI problem. which is, as I just said, AI is a part of the problem and people are freaking out about it, but AI can also be a part of the solution. How? Yeah. Think of the value case of AI. Yeah. Fundamentally, when people describe what can AI do for us, AI does a couple of things, and it's fundamentally described as a productivity use case, right? Which means AI is able to do things more efficiently than humans can because of the speed, of the ability to do massive amounts of computation in small amounts of time, bring intelligence into the picture, actually compute across a very large number of variables, so multivariate analysis, and automate decisions. So you're basically saying, taking humans and their errors and their labor and time, more and more out of the picture, putting it in the hands of AI and helping AI drive good solutions. AI can help drive productivity. Here's the problem with those AI business cases is what I would call the shifting burden of cost, right? And this is my push now is when we talk about AI, we need to talk about a holistic business case for AI. Let me explain that a little bit, right? When you save dollars in one place, you're increasing costs in another place by not taking care of your carbon emissions. So for example, and let's use Microsoft as an example, but not to pick on them, AI is doing phenomenal things now from a Microsoft perspective, but what they've done is they've shifted that economic cost into a carbon cost, which translates back into an economic cost. So we need to build up the mechanisms and the complexity to say, let's frame up a holistic case, the new green math of AI, right? That is looking at complexity, cost, and carbon all together as one. Yeah. But here's the thing, right? When you start framing it up that way, then you're able to actually optimize across a number of variables, bring them together, and have it deliver value. I'm going to use, since I talked a lot about the impact on data centers, let me just explain what's happening in the data center and how AI can help it. All right. So a data center fundamentally is broken up into the following components. You have your technology that's in the data center, which is storage and compute technology, and then all the networking components. You have your power and your power management systems, and you have your cooling and cooling management systems. And all of this is wrapped into a facility. When you have these things working together, now basically you need power, you need cooling to run the technology. It's generating greenhouse gas. It's like emitting heat. You need all of those things to kind of work in concert. AI now has the ability to operate at multiple levels, provided we are able to kind of unlock those cases. We've barely scratched the surface. In our storage technologies, as I mentioned, Hitachi Vantara is a data infrastructure company. We make data storage. In our data storage, we've used AI and we've used high quality engineering to optimize the way the storage is constructed and made so that we have technologies called dynamic carbon reduction. What is it? It's basically saying you track the utilization, and as we kind of, reduce the utilization, we're able to kind of like power down, go into eco mode. We have something called automated compression switching, which is basically saying, what is causing the use of power and the generation of heat is when data is processed. So the less volume of data you use when you are able to compress data, or the less you move data around, the more efficient you're being with power and heat and cooling and all of those things. So our storage technology is able to now optimize across all of these parameters and generate the best quality, the greenest output. But it doesn't come by accident. It starts by eco-design, which means when we are constructing the technology in the first place, we're saying, how can we achieve not just a high performance outcome, but the most green outcome? Now let's start kind of like building it bigger. We've talked about storage. Now storage and compute and how they work together. But now storage and compute and power and how they work together, which means optimizing the use of power, optimizing the need for like heat capture and how cooling solutions work. AI is playing at this micro level, but then AI, when you start combining like a systems of systems approach, not just optimizing a single system, but optimizing across a variety of systems, now you've got something really powerful. I'm going to make a little bit of a pitch, right? But this is a really interesting use case. Hitachi, as I mentioned, is a multi-BU kind of conglomerate. Apart from data storage, we also have a BU called Hitachi Energy, which, by the way, manages power solutions. And we've got another part of Hitachi that manages cooling solutions. Guess what? When you combine all of these things together, and you have this integrated layer of software and services and management across them. Remember what I said earlier about AI being able to do multivariate analysis. Here's a variable, here's a variable, here's a variable. Put them together and optimize across them. Now we're talking about real power. But here's the thing, right? Right now, what I'm describing is so early stage and so conceptual. This is basically where a lot of innovation is going to occur over the next 3 to 5 years, which will mean all of the assumptions that we've made around power sources and reusable or renewable energy coming from the outside and what the data center needs, we can rethink some of those assumptions because the demand is going to change. The utilization is going to change. We're going to be able to use AI to optimize. That's the gist of it. I can dive into it a little bit more detail, but hopefully that kind of paints a little bit of that picture. Yeah.
Yeah. So, we talked a little bit about how businesses might struggle to find a reason to invest or spend on sustainability. The example that you just shared around building a greener product by design, I'm hearing, cost savings if you have lower energy use, right? Because power costs money. How else do businesses assess the opportunity to invest in sustainability, and how does that help them in a competitive landscape?
Yeah, no, this is such a powerful area of emerging thought, I think. I mentioned that I've been attending a few events over the last year, and some of them have been so dramatically different based on geography. When I'm having conversations here in the US, and for example, a few months ago, I was in a conference where we had a lot of policymakers in Washington, D.C., and they were talking about, there's a resistance towards regulation and the focus is on innovation, which is good, right? Business and business outcomes. A few months later, I was in Europe and I heard a very different message. They do sustainability for sustainability's sake. It is the number one driver, right? So, number one, there are differences in how business is prioritized depending on where you go. And we have to understand that and cater to that. But that being said, one really interesting conversation that I had with one of the European Commission policymakers was about how when you're able to explain to people how the green transformation and digital transformation and business competitiveness all go hand in hand, what he calls the nexus of these three, now you start to actually get businesses' interest. You talked about cost saving. That's a really, really powerful one. You may take on short-term costs, but there is long-term benefit and economies of scale that actually don't just pay for themselves, they actually dramatically reduce your cost. As an example, again, the Hitachi Vantara example, we worked with a couple of companies where we were able to improve their performance, but at the same time, improve performance by 90% while reducing their power usage, electricity usage by 66%. Reduce their total cost of ownership by 30%. So now they're seeing the best of both worlds. They see the ability to kind of benefit the planet while saving costs and then reinvesting that in other areas. Not just that, sustainability becomes a competitive differentiator and an angle, right? You understand, right? So when you say, take any company, when the product is more green, it now allows you to position ahead of others. If you can position yourself to say, not only are we achieving strong economic outcomes, we achieve additional outcomes that benefit our stakeholders, society, and the planet, you give people a reason to buy. Hitachi calls that concept the double bottom line, which means apart from your regular bottom line, which is economic profit, you have additional benefit, sometimes quantifiable, sometimes not non-quantifiable, that benefits customers, partners, shareholders, stakeholders, society, and the planet at large. You asked me why I'm so passionate about working for Hitachi. This is exactly the reason. I like the fact that we're able to create a mission outcome based on that.
Yeah, I think that aligns well with ClimeCo as well, right? We are focused on environmental impact, on driving sustainability, on using market-based mechanisms to improve real-world outcomes. And, fight this huge battle that we have with climate change, right?
That's right. And by the way, it's not just on the cost side, right? There's a bottom line benefit and top line benefit. Some of the innovation that you can unlock, you were talking about renewable energy sources before. Here's a really powerful example. Mike, again, I like to pick on Microsoft, but Microsoft has a really powerful example of how they worked with one of the labs. I believe it may have been the Pacific Northwest lab, but they used AI to identify a new form of lithium battery that is 70% more efficient than the existing kind. They didn't find that on their own. They used AI to detect and find it, right? And again, it's AI to the rescue, right? And so I believe if you're really able to kind of like understand the value of data digitization and then put AI to use, make AI work for you rather than you fighting against fighting against AI, this could be a really, really powerful tool in your hands.
Right. And I think that goes to how do we use the tools that we're developing? Because if I'm just an individual consumer user searching for, I don't know, the best deal on Halloween attire or whatever, right? Something seasonal. I might use ChatGPT to recommend costume ideas. I don't know. Is that really an efficient way? Do I ever see the impact as a user of what the emissions are associated with that? No, you really don't, right? So that becomes kind of a public cost, right? I'm spreading those emissions and that energy use to impact our overall system.
And it's the providers of those technologies that basically need to be able to guarantee that they can manage the impact. They're delivering a benefit, but they have to manage the cost as well. Yeah.
I think this is going to be an ongoing opportunity for innovation and challenge, right? And I think one of the reasons we talk about Microsoft is because they are really a leader in trying to drive sustainability and kind of build those business cases. So I think that they're very commendable in how they're approaching this and really trying to kind of open up the ecosystem and demonstrate examples of success.
And what they're doing, which is, again, to your point, commendable, is at this intersection of industries, like I said, right, again, focusing on the data center, the ability to be able to have software-driven or data-driven solutions that can intersect between power and cooling and your technologies, right, and optimize across them. This is a problem that everyone's trying to solve. Again, at these conferences that I was at, it was really amazing to see some of the innovations from companies like Google and Microsoft and others in helping cater to the problem. But it does require you to do it responsibly, right? When I say responsibly, I mean sometimes we dive headfirst into technology and then punt the handling of the issue to later, right? We kick the can down the road. We pass the problem to a future generation. What I believe is happening in this moment is a critical mass. We've reached a tipping point of realization to say, we don't have a lot of time on our hands, guys. The impact is so significant. Like whether or not you cared about climate change, there is definitely a problem you can't escape, which is the stress on the grid. There isn't power to be able to power what you need to do. And when companies realize that, then they say, all right, my innovation is going to be balanced with my responsibility and how I put stuff back and how I drive efficiency. So that's really powerful, right? And Hitachi is proud to be a part of that journey as well.
And, we talk about energy demands and how much renewable energy procurement really reduces the carbon impacts of AI and data centers. I think that's one piece of it. The other pieces are, the physical infrastructure, the embodied carbon in the buildings, the data centers, your technology, the, cement, all of that. So, ClimeCo participates in the REC trading market. So that's renewable energy credits. We advise companies on how to reduce their carbon footprint. And that often includes renewable energy as kind of one of the first steps. And we help source that. So I'm curious, how much do you think renewable energy is the solution, or is it one piece?
It is absolutely the solution. It becomes a fundamental foundation of the solution. Let me just frame it this way, right? A lot of people have pointed to the fact that there was projections maybe 20, 30 years ago about how energy demand is going to grow. But when you look at real demand, what ended up happening is you saw it kind of flatten. And people are like, why does it flatten? It's not that people did not need more energy. It is that at the same time that the demand was growing, it was being managed through efficiencies, being able to kind of drive technology and other efficiencies to kind of keep it at a level. Right now, that calculus has changed because AI is driving demand much faster than the ability to drive efficiency. It has a couple of implications, right? One implication is we've got to invest in innovation in the efficiencies, or we will be in a deep hole. But I think the second part of it, which is quite encouraging, is the fact that renewable energy and the cost of renewable energy is based on this, on the idea of critical mass. It has been a barrier to entry before because the technology is expensive. But when you have enough people participating in the system and demand reaches a certain level, the cost starts to come down pretty dramatically. A lot of climate scientists have actually talked about this. We're at that point where the technology is widely available, ready to be unlocked the moment demand is able to kind of catch up to it, and then renewable becomes a much greater percentage of the overall supply. I do believe that fossil fuels, of course, cannot be the answer, right? Renewable energy is the answer, but innovation and economies of scale in renewable energy will be basically what gets us to that next stage. 5 years from now, we'll be having a very different conversation.
Well, I'm excited about that. I'm excited to the concept of how the conversation would evolve in 5 years, and how our grid evolves to respond to the demands of data centers and data processing that requires so much energy, and how companies are using AI to, make better decisions, including building more sustainable products and meeting their customers in a more efficient way. So looking forward to that, Simon. We'll be in touch on that follow-up to check in on that. But thank you so much for your time today. Do you have any closing thoughts?
Yeah, you talked about the grid, right? And how the grid evolves itself. We know now, like the concept of the smart grid is now being better understood. The idea of the smart grid, that it's not just a two-way flow of power, but a two-way flow of information, is a great example. Just to tie back to where we started, Industry 4.0, the physical world and the digital world, where they intersect, that's where magic happens, right? And so I think for all of us, it is contingent on us to put our money where our mouth is, to invest in digital upskilling of people so that they are able to bring digital to whichever field of work that they're in. See AI as for the problem that it is, but also for the solution that it can be. Again, like you said, I'm very excited to see what the next few years have to hold.
All right. Well, we'll be watching. Thank you so much, Simon.
Thank you, Erika. I'd love to be on. Thanks. Cheers.
Whether you're a seasoned ESG practitioner or embarking on your sustainability journey, ESG Decoded is your trusted source for inspiration and actionable insights for responsible business practices. New episodes drop bi-weekly on Tuesday mornings. Make sure to subscribe on your favorite streaming platforms to be notified, and connect with us at ESG Decoded on social media or by visiting ClimeCo.com.